A magnitude 7 earthquake strikes a major metropolitan area. Within seconds, emergency operations centers are flooded with data, satellite feeds showing collapsed overpasses, thousands of erratic 911 calls, and massive social media distress posts. No single human dispatcher can scan all that footage, triangulate the civilian pleas for help, forecast the damage to the power grid, and instantly route ambulances around debris. The sheer volume of information outpaces human cognitive limits. Predictive AI can calculate the exact probability of an aftershock hitting a specific neighborhood within the hour, but that system is strictly reactive. It outputs a number, and then it stops. It cannot dispatch a fire truck. Generative AI can instantly draft a perfectly worded evacuation alert for that neighborhood in multiple languages, but it just sits there, waiting. It needs a human to hit enter. This is the prompt bottleneck. Right now, human operators are the limiting factor in emergency response and in daily enterprise workflows because they have to manually connect the prediction to the generation, step by agonizing step. Agentic AI bypasses that bottleneck. Instead of a reactive tool that waits for instructions, an agent acts as a proactive collaborator. Effectively managing a crisis at this scale requires a system that handles these low-level connections on its own, freeing human decision-makers to focus on the high-level strategy. Agentic AI is a compound system. It takes a large language model and shifts its role from generating text to acting as a central reasoning engine. It becomes the brain that plans and executes a complete workflow. It starts with perception. The agent operates autonomously, pulling in live information from external environments, like reading satellite imagery, scanning social media streams, and checking IoT sensor data. Once it has that data, the agent uses a process called chain of thought. It essentially talks to itself, breaking a massive goal down into logical, sequential steps. First, it identifies the distress calls. Next, it checks the local weather conditions. Then comes planning and tool use. The agent reaches out to external applications via APIs to do the physical work, whether that's booking a transport truck, updating a database, or opening a physical gate. But it doesn't just fire and forget. The agent reflects. It looks at the result of its action and evaluates if it actually moved closer to the original goal. If an API call fails or a route is blocked, the agent doesn't crash. It loops back, reconfigures its internal plan, and attempts an alternate solution. This continuous cycle of perception, reasoning, action, and reflection turns a static model sitting in a server into an active, autonomous worker. This diagram illustrates agentic orchestration. When an operation becomes too massive, the single agent isn't enough. A central coordinator acts as the main hub, delegating specific tasks to specialist subagents, like analyzing structural integrity or triaging inbound communication. All of these agents work in parallel, communicating through a shared situational memory map. If one agent finds a critical data point, it flags it in the memory for the others to see and act upon immediately. This scales across any industry. In a corporate human resources department, you can have specialized subagents working together to onboard a new hire. One handles the payroll setup, another provisions IT access, and a third verifies legal documents, all simultaneously. By orchestrating multiple agents at once, artificial intelligence handles complex, multi-departmental operations that would otherwise require an entire human team to coordinate. The industry is shifting toward compound AI systems. The base monolithic model is no longer the final product. The value is now in how these models are orchestrated to use external tools and reason through complex data. Because these systems write their own multi-step plans and recover from their own errors, our relationship with the machine changes. We stop being prompters trying to coax out the right text and start being directors. The human's job is to define the high-level objective and review the final outcome. The agents navigate the infinite iterative loops of execution in the background. As interaction moves from passive chat to autonomous execution, AI becomes a partner in navigating the complexities of our physical and digital systems.